Hola, JNation. Thank you for joining. It's a beautiful conference, beautiful weather. I'm originally Moroccan, moved to Stockholm 3 years back, and the heat started to get me, so I'm slowly becoming a Scandinavian. Sorry for that. I'm Mohammed, quick intro. I work for Spotify as a backend engineer. I'm a Java champion as of yesterday, so thanks to all the Java champions that nominated me. Thank you. And I'm also a Google developer expert for Google Cloud. So for the next 15 minutes or so, we're going to talk about machine learning and the language that is not very known about doing machine learning stuff, which is Java. Language that I'm in love with for so long. I've been using it for at least the past 10 years in production. So I said, why not? Discovering what we can do with Java in the machine learning space. And before diving into the technical part, I mentioned it earlier, I moved to Sweden a couple of years back, like 3 years exactly. And then moving to a new country means a lot of things. Not necessarily good, not necessarily bad, but a mix of both things. One of the things that I had to do, and I imagine all immigrants has to go through, is learning the language, which enables you to learn the culture and get immersed into the culture. So you're an immigrant, you want to know what's happening around you, you want to have a conversation with the locals to at least be part of the society and the culture. Learning a language is not actually an easy task. So we'll be looking at how people, or how to crack basically things as fast as we can. We as programmers love cracking things and doing things fast. Like all the best-selling books start with crack or learning fast or whatever. So looked for this book by Benny Lewis. And this book is basically telling his experience how he managed to learn relatively dozen of languages, approximately, and the technique that he used. So what he did basically is travel into the country that speaks the language he wants to learn, and then with the little background that he has and the little words that he knows, just speak the language with the locals. No English whatsoever. And then what he does is basically start speaking the language, the locals will help him to correct the pattern, and then he will start building the patterns that enables him to build the knowledge. Now, to learn a language, there is two patterns. What Benny suggested is basically just immerse yourself with the culture, with the locals, with the people, and start speaking the language. What happens is you will fail a lot. You will miscommunicate much more, and then the locals will help you to correct the pattern. So basically, that's the learning by pattern. So you will correct, and they will correct what you say, and then you will learn that for the next round. And you will not learn the most grammatically correct language, but you will learn enough in order for you to have a meaningful conversation with the locals and the people that speak that language. The second one is what we all learn in school. It's very structured. You learn the grammar, you learn a little bit of the words, and then it helps you to build the syntax of the language and how the language is actually built. So we learn the subjects first, and then the verb, and blah, blah, blah. So we learn the syntax and the language and how its sentence is composed. So it's very ordered. And when it comes to programming, we are more into the second part. We, as programmers, are rule makers. So compared to the language, we learn the rules. So we, as programmers, our job is basically to dictate the rules to the machine in order to make it smart. So our job is writing the rules that we want. No matter how fancy your architecture is, no matter what pattern you use, microservices, container, whatever, you're basically writing rules to tell the machine to behave the way you want it to be, and making the machine actually smart to execute the task that you want. The picture in the example dictates a couple of things. Let's imagine that your product manager came in and says, hey, I want you to model a person that is walking. So you take that and you try to come up with a set of rules that enable you to model the real-world scenario of a person that is walking. To do that, come up with a set of rules, come up with a unit of measure, and that unit of measure is actually speed. So we say, if the person is less than 4 units of measure, you consider that person as walking. You ship it to production, it's working, it's fine. So that's your rule, basically. Then the product manager came in, because that's what product manager do. They ask for another feature. And that's to model a person that is running. So you use the same unit of measure, which is speed, and then you say that if the person is having less than 4 units of measures, it's walking. If it's more, then you consider the person of running. You deploy it to production, a lot of success. Product manager came in again, asked for another feature, modeling a person that is cycling. No matter. Like, it's not a big a deal. You use the same unit of measure, which is speed here, and then you add a new unit, which is 12. So if it's walking, otherwise it's running, otherwise it's cycling. So up until now, we'll be using the same unit of measure, which is speed. And then the product manager got really excited and asked you to model a person that is playing golf. Now, that is really challenging because the unit of measure that you have been using is actually not applicable when playing golf. There is no speed. The person is actually standing and just moving his shoulders. And that's when a lot of complaints starts, and then what we call the projects become a legacy, because our set of rules got so stretched that we can't add anything else. So basically to say that we programmers are rules writers. And the way we made the machine smart up until recently was basically to dictate the machines the rules and pass it the input and to try to match as best as we can the answer. And when the answer doesn't match, we basically tell that's a bug, and then we try to correct the rules that we introduce, which is our programs, and then to match as best as we can the answers. Machine learning is actually the opposite. Machine learning is actually the art or the discipline of feeding the machine with the answers and the data. We put it the input and the expected output, and we let it figure out the rules. So we are no longer part of the rules-making process. We are more into collecting the data process and making the data meaningful for the machine to learn by itself. And that's basically what machine learning is. Machine learning is basically the science and everything that enables the machine to learn by itself in an autonomous way to make the rules in order to match as much as possible the expected answers that we want. And then the more the data is correct and predictable, the more data we have, the more precision we have, and the more the rules that the machine comes with are actually better. And when we talk about machine learning, there are a lot of words, especially in pop magazines. They mix and match a lot of terms. The artificial intelligence, machine learning, a lot of things, they seem to be the same thing, but they're slightly not the same. Artificial intelligence is actually everything that we are talking about. Is a discipline that started back in the 60s in order to make the machine smart. So basically, the idea is done a lot of effort in order to make the machine behave the way we want them to behave and make them smart. So they achieved a lot of progress, especially in the fixed, well-known issues, like playing chess. Artificial intelligence excels in that, but the moment we put a fuzzy problem unknown, artificial intelligence as a discipline shows its limitation. And then machine learning as a subfield of artificial intelligence as a whole is started to be known in the 90s, and it is the most popular subfield of artificial intelligence. And it deals with large amount of data, and it deals with fuzzy problems, like classification of images, NLU, and all of that. And a subfield of machine learning is actually deep learning. So machine learning is basically feeding the machine with the data and the answers and let it figure out the rules. It's a discipline or kind of a similar thing as statistics. It's a subfield of statistics as well, mathematical statistics. However, it differs from mathematical statistics the same way that chemistry and medicine differs from each other. So machine learning deals with large amount of data, which traditional mathematical statistics doesn't deal with necessarily. So machine learning is a subfield of mathematical statistics that specialized in learning with large amount of data. And then comes deep learning. So with machine learning, we call it more there's two types of machine learning algorithms. We call them shallow learning and deep learning. Shallow learning is one layer. So basically, you feed it with the data, it compute it, and then comes with the model that has one layer. Deep learning actually is having multiple layers. And the deep in deep learning is actually represents only the depth of your model and of your network. So that's why it needs a lot of resources, because we are, instead of doing the computation in one layer, we are condensing and multiplying the number of layers. So the deep in deep learning is actually comes from the depth rather than in relation with neural, how the human body and the neurons work, or the human brains work. And then the last thing is generative AI that we're all speaking about recently. So generative AI is basically a subfield of machine learning, deep learning, and it deals with internet-wide data. It deals with a large amount of data, large amount of parameters, and it's so up until deep learning, our best job was basically we were telling the machine to predict the same data that it was trained to. So we're trying to predict the answer from the data that it was trained to. Generative AI and LLMs exceeds that by trying to come up with new things. So you have probably heard about hallucination problem in LLMs, and that's actually not a bug. That's actually a feature, because like LLMs are trained basically to come up with new things. So that's what generative AI is. Even in the name is generative AI. So they generate new things, and those things are not necessarily true, but that's how creativity works so far. So we're in the era of getting the machine creative, but we have to be really careful when we are dealing with those things. So hallucination, again, it's not a bug, but actually a feature. So we talk about that, and then what deep learning has achieved so far? A lot of things. Our machines and even phones now have a lot of machine learning features. So we can't kind of live with it. Every app in the world probably have a small machine learning algorithm or deep learning algorithm that is running on top of it. However, when I want to start, there's a lot of issues that stumbled upon. The first one is every tutorial, every book that was speaking about machine learning has to have at least one section about math, about statistics, linear algebra, vectors, gradient descent, and all of that. Now, I wasn't good in math in school, and I did enough to just pass and don't look back at it. So whenever I opened the book and found that, it's like, thank you very much, I'll pass. The second thing was Python. Now, Python is the dominant language when it comes to machine learning. Python is a great language, except when it comes to being environment friendly. But except that, it's a great language for data science and machine learning. However, I'm a Java developer. I would like to have an option. I would like to use Java when it comes to machine learning. And luckily, I wasn't the only one. A lot of people within the Java community started to the thought process around how we can make Java plays nicely with machine learning. And example here, Humphrey wrote a whole blog on how we can improve Java in order to make it a good citizen and plays nicely with machine learning and deep learning more precisely. And then you'll probably know that if you're a Java developer, Java is good for a lot of reasons. Scalability and performance, the WARA principle, integration, it's the dominant language in the enterprise world, and most importantly, the community support, or the community and support. This conference is a great show of how great the Java community is. And then the rest of this presentation is going to be basically, we're going to walk through 3 frameworks and 1 JSR. JSR 381, Visrec, and 3 other frameworks, Oracle Tribuo from Oracle, the deep learning for Java from Eclipse, and then the last one is DGL from AWS. Starting with JSR 381. It's JSR, Java Specification Request, that is called for short Visrec. So it's a proposal to standardize the way we deal with machine learning, especially when it comes with visual recognition. And it standardizes the way we do it, making it less verbose, more Java-friendly, and it deals specifically with image processing and video processing. Things like image classification, object detection, and it also supports transfer learning and so on and so forth. I think better than having it a demo for it, right? So before that, how many of you watched the Silicon Valley series, TV show? A couple of hands. Okay. So Silicon Valley was a few years back, 10, 7, yeah, 5 years. No, beyond that, 7. So Silicon Valley was like American TV show. It's when there was the Silicon Valley boom and startup boom and the internet boom. Basically, has this shows in ironic way how the Silicon Valley works and San Francisco startups, how they're pouring money in kind of dumb ideas. In one of the episodes, one guy started a very cool app called Hot Dog or Not. The excitement was big because like the promise was it's going to detect. You point your camera to a plate, to a food, and it will tells you what the food is actually is. However, that's the case with every project, right? The expectation and specification is big. The delivery is not so much. So what he delivered is basically a app that basically, when you check a picture, it tells you if the app is a hot dog or not a hot dog. That's actually what the app does. And we will try to build the same thing with JSR 381 or Visric for short. But that's the video for the scene that was happening. So Visric, first thing, hello IntelliJ, hello. See that? Brian, do you see that? I don't know what the problem with IntelliJ. It's like it's becoming weirder and weirder. Okay. Okay. That's better. So you see how small and condensed it is compared to a Java program, right? It's like less than 10 lines of code to train your model, basically. So what we will do is have a list of test data or train data. So we have our data set. It's basically had a test and train folders. So I basically get them from, I forgot the name. I will mention it. Kaggle. So basically Kaggle have a lot of data sets, a competition, and one of them is hot dog or not hot dog. I have my training set, and it has a lot of ugly hot dogs pictures, and in the not hot dog, ugly picture. Oh, that's not so much ugly, but other things that are not hot dog, basically. So basically, we will train our model on those data sets in order to generate the image. So the model would be 3 things. So we will have our image. We'll do some modification for the image, basically. We will align them because like, the images are from different sizes, and we want the image to be standardized in order to have better results. So we will resize the images, all of them, to be exactly on the same size. And then we will split the images into multiple tiles. So the image 128 by 128, we will split it into multiple tiles, small tiles. And then our algorithm is called convolutional neural network. It's one of the algorithms for neural networks. So we will look for interesting parts for each tile. And that's what we call convolution. So we will split the image into tiles and then look for interesting parts. And then we will do some subsampling, which is we'll take those interesting parts and condense them into an array. And then we will repeat the same thing, take the generated array and then feed it to the next layer in our neural network and deep learning algorithm. Then we will repeat the same process for all the layers that we have, and then we will do subsampling, which is to match if it's actually working or not. So what we will have, since we are dealing with images, we have an image classifier that deals with images. In this case, Java, buffered images. So the input class is an image. We are specifying the width and the height of our images. We are specifying the labels in a JSON file. I like how they went for the convention over configuration. So we have, not this one, labels the text. Since we are having 2 labels that we want, it's either a hot dog or not hot dog. That's exactly what we want. That's what the app should do and exactly what we do. And then we have the training file. And the training file is basically the index dot something. Yes, this one. So we took all the data set that we had and then we labeled it. So that's basically the path of the image and then the label that match this image. So we're telling our algorithm, this is the image, this is the data, and this is the answer part that we're feeding it. This is the image, and this is the label that matches it, basically. So the algorithm and the model will basically learn from it. And then we'll have our network architecture. A lot of, even in the Python world, a lot of frameworks and libraries actually define the neural network architecture in the program. With Visric, they went the other way and then defined it in a JSON file, which I find really cool. So we're basically doing the same thing that I said, like convolutional max pooling and then subsampling, or convolutional subsampling and then max pooling. So we are basically defining our input layer, defining our convolutional layer, which basically splitting the image into multiple tiles, looking for interesting part, converting it into a matrix, because that's math, and then condensing it, keeping only the interesting part, and then feeding it to another layer. Here, I have only one layer, which is cheating basically, because there is no deep learning with only one layer. But that's enough for training the machine, training the model on my machine, which is an M1 machine, 32 gigs, which is not bad. I was training it on a plane while coming here. And then fully connected, which is by condensing everything and checking if it's matched. And then we have the output layer, which is basically the last layer that we have. So in every deep learning model, we would have the input, the output, and then the fully connected. And that's pretty much it. We have the max error and then other configurations, which has the max error. If the error of the algorithm passes beyond that certain threshold, just stop. Don't continue training your model. Max epoch, how many times we want to do the learning rate, how the steps of the learning. And then when we finish, we want to export the model into hotdog.net, which is here. So I already trained it, already exported it, and that's pretty much it. So basically with this condensed code, 10 lines of code, and some configuration file, we're able to generate a very simple deep learning model. And then to use it, again in Java. You can imagine, this is a simple main class. You can imagine integrate with your favorite Java framework, Spring, Quarkus, you name it. And then what we do here is we import our model, which is a convolutional neural network. We are dealing with images, so it's an image classification model. And then we have our test data. So we have two things here. Hotdog. It's resources, Visric, something. Resources, Visric should be here. So we have a hotdog image, which is very ugly hotdog image, and then a pizza image, right? And then the intention here is pass this hotdog image or the other one, and then expect the model to distinguish if it's a hotdog or not. And then we get the results by running the model, running basically the inference. And then it's a simple model. We would basically assume if it's less than 50%, 0.5, we'll consider it not a hot dog. If it's more than 50% confidence score, then we'll consider it a hot dog. So running it here, it's switched it to the hot dog image. If I run it, if IntelliJ is nice enough, I should get this. The image is probably a hot dog. Yes, that's what it says here. If I change it to the pizza one, it should say it's not a hot dog. So it's basic demo. It should work, but yeah, you got the idea. So that's basically Visric. They went the way of making things simpler, having a lot of configuration files for you to do things rather than having everything in one place, which make the code really readable, and then move everything that is configuration to specific files that you can define, which is really cool. Now moving to another framework or another library, which is Eclipse Deep Learning 4D. They followed another pattern, and they were one of the first libraries that you can do deep learning and machine learning with. They're not so active recently for some unknown reason. I tried to ask, but got nothing. But the idea that they did is basically they defined the Java API. That's basically we use to build, train, and then run our model. So that's the API that we use, which is called Deep Learning 4D. And then they have another linear algebra library that they built, pure Java. It's called ND4G. That's the backbone of deep learning 4G. That's run the math that has all the functions, the methods, everything math specific that they use in order to make all the magic happens for deep learning 4G. And they benefit from a library called ByteDeco, which is a Java or a C++ library. And it does basically the switch between CPU and GPU. So with deep learning 4G, you can run your model or your training with CPU or with GPU, and they benefit from that from libnd4G. And they have a data library, which is basically an ETL library. It has a lot of support for a lot of neural networks algorithm, a convolutional neural network, FNNs, RNNs, and all the major neural networks that we have or that we know of. And then they support exporting and importing from other frameworks like PyTorch and TensorFlow and Keras. Deep learning 4G is very inspired from Keras. If you ever worked with Keras, you would find that the same thing applies for deep learning 4G. It's the same thinking, the same kind of APIs, the same way of dealing with things. ND4G, as I mentioned, is the backbone. It's a linear algebra mathematical library, so it enables them to do all the magic that they did. It has distributed training, and I think with combination with Spark, it goes even more nicer. Then it has multi-language support. Java and Scala, first-class citizen, they tried to do a Python API, but didn't work very well for them. And they have models.We. And models.We are basically a set of well-defined pre-trained models that you can use in order to, without doing the training, they are pre-trained for you. You can use them in your favorite or your production environment out of the box. Doing the same thing with deep learning 4G, look how longer the class actually became. Maybe zoom a little bit, remove this part. So deep learning 4G provides you with all the set of tools. Provides you with a toolbox, and they let you pick the one that you want. So it offers you all the tools that you would need, but then it comes with at the price of verbosity, and you would need to define everything on your own. Starting with defining your destined data set and training this data set. It offers you the possibility of switching and transforming your image. So the images we have is a couple of hundreds. That's not enough to train a well-defined model, right? Powerful model. So what they support is basically image transformation. So we can rotate the image, flip it, make it black and white, do a little transformation so we can have a bigger set of images for the model to train for more data. So they have that, and the one that they have is basically resizing the image. And then that's the definition of my neural network. And look how big it is. It's the same thing. He said I would rather have it in a configuration file rather than here. But yeah, that's what deep learning 4G did. And then it's almost the same thing, but with more machine learning stuff. So I find that with deep learning 4G, you need to know some of the things to get started rather than VisRec, which is like you can start without knowing all the things. For example, the activation, what does it mean? What algorithm should I use for activation for what use case? So those are the questions that you would need to ask, but they have a great documentation on the other hand, which is fair enough. So we define our neural network architecture with a set of options, and then we start defining our layer. It's exactly the same thing that I did earlier. So we start with a convolutional neural network, splitting the image into tiles, getting to the interesting part, feeding it into the subsampling layer, which is trying to condense everything. And then here I have two layers. So I took the matrix that was generated from the first layer and pass it to the second layer, which is another convolutional neural network, which tries to look for the interesting part in each of the matrices and then have the subsampling. And in the dense layer, it's actually the max pooling and then the output layer, which is the end layer that basically generates labels. And then that's pretty much it. So we defined our neural network, and then they have this thing called UI server. So it's basically a web image that you can embed on your application, and it sends data events to a web UI application that you can watch how your training is actually going. It's very useful, especially if you have a multi or distributed training. And then we're loading the data. That's everything that you can define. Notice that for Visrec, we didn't define anything. The library and the GSR took care of everything. So we're loading the data, setting up the model and some of the configuration here as well for the web server UI. We're training the model, and then we are evaluating the model, which is basically have a training data, and then to see if the data is good enough or the model didn't do an overfitting or underfitting. So we're passing the test data to check how confident our model is and how compared on how precise it is compared to the test that he did with our training data. And then we save it. It's exactly the same thing that we did. So that's a little bit more verbose, but it provides more tool set for you to work with and to do more fine-tuned building of your neural network model. Another thing that deep learning 4G supports, it's what we call transfer learning. Transfer learning is, the idea here is basically there are a lot of good models in the world, especially when you come, for example, in image classification. Imagine that you have an image classification as we have now. There are a lot of image classification models that are available in there. So you can use that, one of those models, and you can fine tune it in order to build your own model. And this technique is also supported with deep learning 4G. So the definition is exactly the same thing, but the number of layers is actually smaller. So we have only 2. So we are importing our neural network, which is a ResNet model. That is a very well-known image classification model. And then we are adding another layer, which is basically adds another testing, another training for the set that we want. And then everything else is exactly the same. So another feature that's supported in deep learning 4G, but not necessarily for GSR 381. Use cases for DGL, deep learning 4G, a lot of things. So it supports image recognition, that's what we show. It has also, you can use other use cases such as natural language processing, NLP, building chatbots, virtual assistants, and so on. You can build robotics and games with deep learning 4G if you want to. However, it has a steeper learning curve compared to other frameworks. And that's because they offer you all the tools and all the sets and the rich API that is a little bit more verbose. And that's because they have a lack of high-level abstraction. If you want to get started, it's going to be a little bit harder for you to do that easily. And then it's primarily focused on deep learning and neural networks. So if you just need some simple machine learning, such as regression and classification, deep learning 4G can be challenging. And as I mentioned that in the beginning, it has a slow release cycle, which is starting to get a little bit worrying. The third library, or the second library is actually DGL from AWS. And DGL followed a completely different model. So instead of building their own engine, what they did is piggyback on the known engines that we have in the machine learning community, such as PyTorch, TensorFlow, and others. So they took those machines, put interfaces that basically forward to those machines and use their APIs, and provided a tiny Java API on top of those machines, on top of those frameworks and libraries. So it enabled us to be using the same things as everyone else in the community, or especially the machine learning community, and then use it with a Java API, with a Java flavor, which make it a lot more interesting. So they benefit from the presence or the things that we do in the other Java or machine learning frameworks. They have another thing which I like very much, which is called DGL server. So imagine that you don't want to deal with machine learning at all. You just want to get an API from somewhere and then use it, right? I hope that I have Insomnia open. It's built-in. So DGL serving is a very basic web server, web API, that's basically localhost 8080. That basically, forgot to download the model. It's basically, you can upload a model to it, and it provides two sets of APIs. The model API, which lists you which model you have, what specification of all the models that you can upload, and then it provides you with a prediction, which is based on, you can pick a model that you already uploaded, and you can do prediction based on those models. I have one that I didn't already load. Is it trace? Yeah. So here I just uploaded a model, which is trace ResNet, the one that I mentioned in Deep Learning 4G. I just downloaded it from the internet. It's basically PyTorch one, and then I will just upload it. It will take a couple of time, but it's available. So the model here is ready, as you can see. So I can basically use an API or a REST API to call it basically. So I will go to Insomnia and try to collections. No, that's work. That's so I have two, as I mentioned, two set of APIs. The first one, the models list all the APIs that I uploaded, or the models that I uploaded into the DGL server. And here it says that I have trace ResNet 80 available and ready to use. And then here, I want to use the ResNet API or the ResNet model. So what I can do is basically try to go here, change the image, pick an image of something. Okay. And then sit. Interesting. Okay, what's the name? Trace ResNet 80. Okay. It should be here. Trace ResNet 80. And then it will run the model and provide me with a list of image classification and the probability. So it's the probability of being a hamster is basically 85%. So in the real world, you won't probably need to build your own model. So you'll either use one that is available and tune it basically to serve your need, or using transfer learn, or basically use one of those models. Because if you want to detect sensitive images or images that you don't want to use your user to upload to your platform, you can basically use one of those models that are already available, and basically use DGL server, and through a REST API, you can basically build anything using Java. But it supports everything using Java API. Another thing that I want to use, do you know Google Colabs? So Google Colabs or Jupyter Notebooks, they're a very known thing within the machine learning community. They used to be only Python, so in order to benefit from them, it's basically machines that some of Google, for example, offers, and Jupyter Notebooks and a lot of machine learning companies offer, free, that you can use with some constraints to offer you up to 2 GPUs and such. But they used to be very Python focused. But thanks to the JBank folks, we can now have an engine that supports Java. So that's basically the Visric example using Google Colab and Jupyter Notebooks in order to run it. So we can see that I'm using basically here JBank in order to import and install the Java engine. And then it will basically set for me a Java engine, which is based on Java 21. And then I will download my data set and then run my my training, which is really good if you want to do the training on a cloud environment. So that was DGL. Again, DGL has multi-framework support. For TensorFlow, PyTorch, MXNet, and all the known ones. It has a simplified deployment model, DGL server, really cool, really easy to use. And I forgot to mention that it's actually a Docker image that I was deploying. It's basically running in Docker, so it just Docker pull and Docker run, and it was really easy to do. It has an extensive model zoo. It's one of the best libraries when it comes to the model zoo compared to the others. Model zoo is basically a set of, as I mentioned, pre-trained models that you can use out of the box. It has automatic dependency management, basically because it supports multiple engines that are not necessarily Java. So it tries as best as it can to resolve that for you. However, that model compatibility is a problem because we are relying on other frameworks. They move faster than DGL, so there is a gap when they move. Like if a new version of PyTorch comes in that has a feature that was supported but not, you cannot use it until the DGL basically adds supports to it. And it has limited deep learning framework support. I saw that in the community. It's basically, it supports the well-known ones. You will find in GitHub a lot of people trying to add new things, but the committers in DGL wants to keep the focus on the well-known ones. The final one is Oracle Tribuo. And Oracle Tribuo followed a very interesting approach. So rather than focusing on deep learning models, they wanted to focus on machine learning specifically. And they wanted to focus on the enterprise world. So they offered a lot of solutions that help any enterprise company or enterprise environment to get onboarded into machine learning. So imagine you're an enterprise and you want to get onboarded in machine learning. So what you can do basically is Oracle Tribuo. And what it does is you have a CSV or a text file. You have a database. You have a job, a pipeline that is running. So they have a lot of inputs that they can plug into your infrastructure, and they can transform the data for you and then shove it into their data source. So basically, they do the heavy lifting for you, and then onboard it, map it to their internal representation of the data set, and then they do the heavy lifting and then train the model for you. Of course, you need to define your machine learning model and machine learning constraints, and then you will have to train your model basically and run it. It's all in Java, but it excels when it comes in enterprise environments and navigation to enterprise constraints. So as I mentioned, Oracle Tribuo doesn't necessarily have a focus on deep learning models. It only focuses on machine learning models. For enterprise world, the focus, it does a lot of data pre-processing and feature engineering for you. It supports data pipeline. It's really scalable. Again, it comes with a lot of enterprise constraints in mind. So they try to make it a lot more easier for the enterprise world to get onboarded into the machine learning world, which is really cool. So what you can do with Oracle Tribuo, anything that machine learning or classical machine learning excels at. Classification, regression, anomaly detection, because they figured that not everyone needs to a machine learning or deep learning algorithm or deep learning model. Not every problem in the world will be solved by deep learning. Machine learning excels at some point, excels in some scenarios, and they are a lot more cheaper compared to deep learning model because they have one layer, and that's for the enterprise world is saving costs, and most of the use cases doesn't need deep learning. However, as I mentioned, it's not focused on deep learning. If you need a deep learning library, Oracle Tribuo will not be the one that you want to use. It has a less extensive models compared to the others, but they are kind of building it. It has a smaller community, and that's because it's relatively new. It was released during 2020, so it's 4 years old compared to the others. But it's getting a lot of momentum. Keep an eye on it. So, when to use which? My favorite one is DGL, just because it supports deep learning and machine learning. The learning curve is smaller, and it supports PyTorch and what's the other one? TensorFlow. Those are the well-known ones, and everyone is using. So if you want to import and export to those frameworks, especially if you are dealing with machine learning engineers, it will be a lot easier. And it has an extensive model zoo. Deep learning 4G, how to say it? If you have a lot of free time and you want to spend if you want to be an expert in machine learning, if you just want started and get done with it, then probably deep learning 4G will not be the one that you use. And then I mentioned that multiple times. The release cycle is really becoming really slow, so probably don't want to use that unless you know that it's going to be support for it. And then Oracle Tribuo, if you're an enterprise world, if you're dealing with complex amount of data, if you just want to get your data and then shove it into an enterprise model and benefit from machine learning, Oracle Tribuo is really good when it comes to that. And that's just to say that machine learning is an engineering discipline. For multiple years, it tried to say that it involves a lot of math. It's not really so. And then it involved multiple parts that Java was missing for most of it. But now we can use Java basically end to end from the training part up until measuring the performance of our machine learning model. Obrigada.